The demand for EVs has grown exponentially over the last several years. And I'm not just talking about passenger cars. There is more incentive than ever before to develop electric vehicles for agriculture, mining, emergency vehicles, buses, and more. But in order to make these vehicles feasible within those industries, we must consider vehicle downtime. And in order to keep vehicle downtime within the realm of acceptable, we need to talk about high power charging inlets. Hi, I'm Amelia Dalton, host of Chalk Talk. All major truck and bus OEMs will be launching electric vehicle platforms within the next few years. And in order to keep pace with on highway and off highway EV innovation, our charging inlets must also provide the voltage, current, and charging requirements needed for these vehicles. In this episode of Chalk Talk, Drew Reetz from TE Connectivity and I investigate charging inlet design considerations for the next generation of industrial and commercial transportation. The differences between AC only charging and fast charge and high power charging inlets, and the benefits that TE Connectivity's ICT high power charging inlets bring to these kinds of designs. And before we get started, don't forget to click that link. There you can find even more information about this topic from TE Connectivity. Hi, Drew. Thank you so much for joining me.
Yeah, of course. Happy to be here.
So, we're talking about high powered charging inlets today. But, Drew, before we get started, what all will we be covering today?
First, I just wanted to set the stage for the industrial and commercial transportation market that we're focusing on here with these inlets, and then get into some market trends and innovations we're seeing in the space, and then get more down into the charging inlets that we offer with comparing the different charging power levels and the time required to charge. And then finally wrapping up with the specific features on our new TE Hivonics high power charging inlets that we're launching.
Excellent. Now, we're talking about a wide range of different vehicles here, right?
Yes, absolutely. So we have a business unit that we call Industrial and Commercial Transportation. It focuses on a wide range of different markets. The majority would be what we call on highway, and that represents about 60% of our market. And that includes trucks, both medium duty and heavy duty, and then buses, and then as well as the special emergency vehicles like fire trucks, ambulances, et cetera. And then we have another portion that's the off highway, and that is our big ones are construction and agriculture. And then there's also some other specialty vehicles like lift trucks that are used for special situations to transport materials, say in a loading dock area. And then the third area we're focusing on is the recreational and marine. And so this includes leisure marine, but also any other recreational vehicles, side by sides, ATVs, snowmobiles, wave runners, and then even two wheelers, motorcycles. So we're pretty much covering all the vehicles here that aren't your typical passenger car. And so with all of these different vehicle types, as you can imagine, they have some unique requirements and they're exposed to some extreme environments that a typical passenger car wouldn't necessarily see. These include higher voltage and current requirements, and this is because a lot of these larger vehicles require more power to function, and also a need for faster charging speeds. So that kind of goes along with the higher voltage and currents. But when you're talking about a commercial vehicle, vehicle uptime is a critical component to ensure you're maximizing productivity. And then getting into the environmental things like vibration, dust, and gravel, especially on the construction and agriculture vehicles, as well as your power sports. And then some extreme temperatures and moisture that they're usually exposed to because our charging inlets on these type of vehicles wouldn't be inside of a sealed area like it might be on a passenger vehicle.
That makes sense. So, Drew, what kinds of trends are you seeing pushing the need for these kinds of charging inlets?
Yeah, sure. I think as we all know, there's been a lot of focus in the transportation market in general in recent years to reduce our environmental impact. There's been a lot of developments in e-mobility within the passenger vehicle market over the last several years, and we're seeing the same thing happen and continue to grow in the industrial and commercial transportation space as well. And that's important because the impact that these larger vehicles have on the environment when it comes to emissions is actually more so than your passenger vehicles. So, for instance, heavy duty trucking accounts for about 28% of climate pollution within the transportation segment, while making up just 5% of the vehicles on the road. So, in order to achieve these carbon neutrality goals that have been set, we've seen a lot of governments focus on creating incentive programs and tax savings for not only the passenger vehicle market, but also incentivizing the industrial and commercial OEMs and fleet operators to incentivize them to also make that transition to battery electric vehicle to help offset what we've typically been releasing into the environment with the internal combustion engine vehicles. And as a result of those incentive programs and the goals that have been established to reduce our emissions, we've seen all of the major Western truck and bus OEMs either already release their first EV platforms or planning to release within the next 2 to 3 years. And with that comes a growing need for higher power charging solutions because, as I mentioned before, a lot of these vehicles we're focusing on are much larger and have more power requirements and therefore larger battery packs. And in order to make it feasible and actually work for these fleet operators, especially, you need to minimize the amount of downtime where the vehicle is charging. For a typical passenger vehicle car, you could come home, park in your garage, and plug and charge overnight for several hours. But when you're talking about, say, a long haul truck, that's not an option. And I'll get into a little bit coming up the differences in the charging times that we have for different types of charging inlets. But that's one of the major focuses and the challenges that we're looking to solve with these high power charging inlets that we've just launched. And it's not only heavy duty trucks or buses. As I mentioned, we're seeing more demand start to pick up for other markets like the construction and agriculture spaces, and mining is a big one as well, especially when you think about underground mining and the even more so stringent requirements for low emissions when you're working in a underground environment. The capital that's required to invest in a filtration system to make sure there's clean air down underground for the miners to work in. If you can just eliminate the emissions from the vehicle from the start and just work off a battery electric, it makes so much sense in that space.
So, Drew, can you explain a bit about the difference between AC only charging inlets and fast charge and high power charge inlets?
Yeah, sure. So the AC only, commonly known as type 1 and type 2, these are what have traditionally been used for passenger vehicles and what a lot of people might use to charge their electric vehicle if they have one at their home. So this is AC only current up to 32 amps generally at 480 volts. And this is usually pretty sufficient for your passenger vehicles if you have, several hours overnight maybe to charge. But when you apply that to an industrial commercial vehicle with a much larger battery, say for example, 500 kilowatt hour battery, it would take over 32 hours to charge that battery. So that's obviously not going to work for commercial vehicle when vehicle uptime is so important. So that's where we've seen a lot of focus on the CCS or combined charge system interfaces. So there's a CCS1 and a CCS2. CCS1 being for North America, CCS2 primarily for the EMEA market or South America. And what the CCS does, combo charging, means there's that same AC interface at the top, but then introducing also the DC interface at the bottom. So this enables you to charge with direct current, which can be done for the DC fast charge with a 70 square millimeter cross section cable, can support 250 amps at 1,000 volts. And so that alone significantly reduces the amount of charge time for that same 500 kilowatt hour battery down from over 32 hours down to 2 hours. So that's great, but still that's 2 hours of time where the vehicle is not being productive. It's sitting there charging. So in an effort to further reduce that, we've developed our high power charging inlets, which use 95 square millimeter cable or 120 square millimeter cable. And this increases that current rating up to 500 amps and beyond, depending on the ambient temperature, which I'll get into a little bit more. So, moving that up to 500 amps further reduces that 2 hours down to around 1 hour, even a little less. So that makes it much more reasonable for the end user to look at the battery electric as an actual potential solution for them. Whereas if they had to, charge for several hours just to get a full charge from a productivity standpoint, that might be a deal breaker. So the high power charging inlets that we've developed are really focused on those larger type vehicle applications that have the large batteries where charging time is a key focus.
So, Drew, is there any difference in the cable size in these high power charging inlets?
Yes, there is. So I mentioned we have options for 95 square millimeter or 120 square millimeter. So there is some difference in the current ratings. Obviously, the larger the cable cross section, the more current you're able to support. So our maximum continuous current for a 95 square millimeter cable is 300 amps, whereas with the 120, we can go up to 335 amps. So you get a little extra for that larger cross section. And that is with an uncooled charging plug. So that's another important thing to note is whether the plug on the charging station has cooling or not will also have an impact on how high of current levels you can support. So for our commercial vehicles, the majority of the time they would be charged with stations that have the active cooling in the plug side. And so that's where we get ramping up to 350 amps with the 95 square millimeter and 500 amps with the 120. And that's for continuous charging. But we can actually push it a bit higher for a certain period of time until you reach that temperature cutoff of 90 degrees Celsius. This is a standard level that is a safety feature to make sure you don't overheat the system. So our 120 square millimeter cable can actually support 600 amps for 50 minutes, so close to that hour time, or 700 amps for 8 minutes. So you can start out at 700 amps, go for 7, 8 minutes, and then derate down to a lower current and continue charging. But that enables you to charge that battery pack in a shorter period of time if you're able to push more current through. And so at the top here, this is kind of the trends that we've seen when it comes to just the power levels for industrial and commercial vehicles. So in the past, it was around 150 kilowatt, but now we're seeing a lot of vehicles want to have at least that 350 kilowatt power level with plans to further increase that into 2027, 2028, going up to 600 kilowatt, and then 2029 and beyond up to 800 plus kilowatt. And I mentioned also the difference in the AC and the DC charging. So one trend that we're also seeing is with some customers just wanting to have DC only. So we have a variant of this high power charging inlet that we take out the AC lines completely. And that way you don't have to go through the trouble of terminating the cables and populating it into the assembly if you're never going to charge with AC current because it would take so long in many cases. So we're seeing a lot of customers just focus on that DC only charging solution.
Okay, so Drew, give us some details about the new ICT high power charging inlet that TE Connectivity offers.
Yeah, sure. So I mentioned that option to have AC or just DC. One additional option that we offer is a higher power AC. So this might make sense for a vehicle that you'd still want to have the ability to charge with AC, but the 32 amp level is not sufficient. So we've developed a version that can support actually up to 80 amps for the CCS1 or 63 amps on three phase for the CCS2. And that is done by moving from a multi core 6 square millimeter AC cable to individual core 16 square millimeter cables. So this uses the same front inlet housing assembly part, but has a different back cover that enables those individual larger cables to come out the backside. And so it's a modular design that gives the end user the options to either use the standard 32 amp AC, the larger 80 amp AC, or the version that has no AC and just strictly focus on the DC. I already touched on the larger DC cables. So instead of the 70 square millimeter or even the 50 square millimeters kind of standard for the automotive market, but moving up to 95 or 120 square millimeter to support even higher or faster charging. And those terminals are terminated using ultrasonic welding with the larger cross section. We use ultrasonic welding to reduce the resistance there as opposed to a mechanical crimp with such a large cross section. We see much lower resistance levels moving to ultrasonic welding. And there's also integrated temperature sensors inside of the inlet housing assembly on a PCB. There's actually two different temperature sensors, one for each DC terminal, and then another one for the AC area. So that's an enhanced safety feature to make sure that we're not going above that temperature threshold. And then we also have some features that improve the ingress protection or IP rating. So we validate all of our seals to specific cables to make sure that there's always a tight fit, and they're rated up to IP67 and IPX9K, which means submersible. You could take this entire inlet and dunk it in water for 30 minutes, and there wouldn't be any water going into the internal area on the backside where the termination is done. And it's also rated up to IPX9K, which means a high pressure spray. So when these vehicles are being power washed, there's no issue of water ingressing past the seals that are around each terminal. We also have an optional LED feature in the top left and right hand corners shown on the slide here, where this gives the end user a visual feedback to show the charging status. And then finally, our mounting locations on the bracket are the same across all the DC fast charge and high power charging CCS1 and CCS2. So if customers looking to make the transition from the DC fast charge at 250 amps up to the high power charging, they don't have to make any difference mounting bracket on the vehicle itself. Or if there's customers who are developing vehicles for both the North America market and the European market, between the CCS1 and CCS2, those mounting locations are the same. So it makes it an easy transition.
So, Drew, does TE offer charging inlet kits for this solution as well?
Yes. So there is a number of different components that make up the charging inlet. It's one of your more complex connectors with all the different AC, DC, temperature sensors, signal lines going in. It's a lot of different components. And so to make it easier for our customers to get, especially low volumes, because in the ICT market, there's a lot of lower volume production than seen in the passenger vehicle market. And so to make it easier for those customers who are just building lower production volumes or even getting first prototypes, as a lot of customers are just now starting this venture into e-mobility, we have kit part numbers that are created for each configuration that has all the different components that would be used to make up this charging inlet under one part number so that they can order those kits in as low of MOQ as just one piece rather than ordering 20 or 25 different components at higher MOQs. You can just order one kit part number and in whatever quantity you want to make it easier for the end customer. And then in addition to that, or beyond the kits, which is all the components coming in one package, we're also developing pigtails to where it would be standard length, say 2 meters or 4 meters of cable already assembled to the charging inlet.
Okay, so Drew, how about the different variations? How do they compare in this charging inlet family?
Yeah, so there's a lot of different variations. And so I've made an overview here for all of the different CCS charging inlets that TE offers. So the different cable sizes from 70 square millimeters, 95, 120, showing what those current ratings are, and then the cable termination method for the DC lines. And then the different options, as I mentioned, there's versions with no AC or with the standard 32 amp AC or the larger 80 amp or 63 amp AC. And then The DC fast charge 70 square millimeter have an option for the cable exit to be either 90 degrees out the left or the right. And then for the high power charging with the larger cable cross sections, we have those coming straight out the back 180 degrees. And then the LED indicators and the flap assembly, those are optional for any of our different offerings. So whatever the customer wants. And that flap assembly can open towards the left or towards the right. And that just is an accessory that snaps onto the front of the inlet and offers an additional barrier from gravel or dust to get on the terminal on the front side. And then finally, we have two different versions for the locking actuator, a 12 volt or a 24 volt, depending on what low voltage level the customer is working off of. So that provides some additional simplicity for the customer. If they're working on a 24 volt system, you don't need a DC to DC converter to step up from 12 to 24. We just offer the locking actuator in a 24 volt variant.
All right. So, Drew, if my audience wants more information about this topic, what kind of supporting assets does TE Connectivity offer?
Yeah, on our website, we have overviews of the different product portfolios with pages for frequently asked questions that help guide customers through selecting maybe what charging inlet makes most sense for their application, as well as data sheets for both the DC fast charge and the high power charging that we're just now launching. And then we also have a catalog available on our site as well.
Excellent. Well, Drew, I think that's all I have time for today. Thank you so much for joining me.
Thank you. Take care.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from TE Connectivity. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.